Exercise 1.2, question 7. There is a circular path around a sports field. So, a circular path around a field. Let's just have this. So, this is the field, suppose the sports field, and you have a path around it like this. This is the path. Like this. Okay, let's continue reading. Sonia takes 18 minutes. So here's a person who takes 18 minutes to drive one round of the field. One round of the field means if Sonia say starts from this point, say this is the starting point A, then she can complete an entire round and come back here at A in 18 minutes. Then while Ravi, so here's person number 2, Ravi takes 12 minutes for the same. So the same thing happens again. Ravi is also taking a round of the field and he will take 12 minutes for that. Suppose they both start at the same point and at the same time. So suppose this point that I've taken right at the beginning, this point A, both of them start from here. Now it doesn't really look like a point yet. Let me just mark it as a point so it looks like a point. So here, this is point A and both of them start from here and at the same time, say 8 a.m. in the morning, both of them will start. And they also go in the same direction, which means if Sonia is going this way, then Ravi is also going this way. Nobody will go the other side. Nobody will go on the towards the left, for example. Then the question asks, after how many minutes will they meet again at the starting point? So they have to meet again. Why are we saying meet again? Because in the beginning they're both together, right? Both of them started at the same time and from the same spot. So we want to know when again will both of them be at point A. Now it's very simple. Just think about it. So here is person number 1. Here is Sonia. So she starts at point A at a certain time. So in the beginning, say 0 minutes. Then after 18 minutes, she will be back at point A. Then suppose she takes one more round. So she will be back at point A in another 18 minutes. Now 18 plus 18 is 36. Then if you add another 18 to this, you would get 54 minutes and so on. So what is really happening is that Sonia will be at point A after every 18 minutes. So the number of minutes here, as you see, they are a multiple of 18. Each of them is a multiple of 18. Similarly, when you'll work for Ravi, you will notice a similar pattern. So he takes 12 minutes, right? So the first time he'll come back will be after 12 minutes. Next time he'll come back will be another 12 minutes. So in 24 minutes, then another 12, 36, another 12, 48, and so on. So you notice that these numbers are all multiples of 12. Now what you want here is that both of them should reach A at the same time. Now think about it. Both of them had the same beginning, say 0 minutes and 0 minutes. 0 minutes is signifying the beginning. Then after that, when again did they have the same time? This was one spot. The next time you will see here in the lists, it was here at 36 minutes, which means that after Sonia will have completed 2 rounds. This is round number 1, this is round number 2, and Ravi will have completed 3 rounds. This is 1, 2, and 3. Both of them will meet again at point A. So using this diagrammatic approach also, I could get my answer that they will be there together after 36 minutes, and that's my answer. But how do I mathematically solve this without writing all of these multiples as I did? Well, there you just have to think about it. You have to think that if Sonia completes a round after every 18 minutes, then from that stage only, you have to be able to say that the time when she will be back at point A will be a multiple of 18. Similarly, since Ravi takes 12 minutes for one round, whenever he'll be back at point A, the time there will be a multiple of 12. Now, since I want both of them to be together at point A, the time has to be a multiple of 8 and a multiple of 12. So there has to be a connection. Both of them have to happen together. And what does this mean for us? This means that the time that you're looking for, let's just call it t, the time that you're looking for is a common multiple of 18 and 12, 18 and 12. Now the common multiples of 18 and 12 will be infinite. 36, as you saw here in this list, is only the first common multiple that they have, the least common multiple. After that, if you write down the list further, you will notice that 72 is also a common multiple. It will be there in both of these lists. So this actually, the time, the possible time can be a lot of possible values. But you want to know the first time. Yes, the question did not say so, but if they say after how many minutes will they meet again, then that means the very first time that they meet again. So you really just have to find the LCM of 18 and 12. Now, let's just clear up some space and find this out. To find the LCM now, you know what to do. You have to prime factorize both numbers. So 18 is going to be 2 times 3 to the power 2 and 12 is going to be 2 to the power 2 times 3. Now when we find the LCM, we take each prime factor visible with its greatest power. So when you look at 2, the powers it has are 1 and 2. 1 in 18 and 2 in 12. So the greatest visible power is 2 from here. Similarly, when you look at the powers on 3, then again the greatest power is 2 because it's just 1 here in 12. So I take those two greatest powers here. So this becomes 4 times 9 and yet again you get the same answer as you got by actually listing the multiples. So the correct answer for us is 36 minutes.